Welcome back to the Kinect for Windows SDK Quick Start Tutorials. This is the Audio Fundamentals video. So when you look at our series, our first video talked about the Kinect sensor and how it mounts as a microphone and how you can use it with no application writing, with your sound recorder application, and also the Windows speech recognition engine. What we want to do now in this session is show those two scenarios, recording audio and also using speech recognition programmatically. So just to recap, inside the Kinect, we actually have a 4-microphone array, and a couple things that are happening is there's hardware-based audio processing. So what that means is it's on the hardware side, not on the software side. And this includes multi-channel echo cancellation, sound position tracking, so it'll know where the source position is for audio based on the microphone array. There's other digital signal processing going as well, like noise suppression and reduction that you typically find in microphones. Now, the actual classes to program this, you're going to be using either, for recording audio, you're going to be using the Kinect audio source. If you're using speech recognition, there's a set of speech recognition APIs that you'll use. But for the Kinect audio source, what we're going to do is use the start method. And what that does is returns a stream to us that represents the actual buffer, the recorded audio from that microphone. Now, there's a number of different properties within this Kinect audio source. I mentioned the sound source position. You also get a sound source position confidence. How confident are we that that is the correct sound source position? There's different ways to set up the microphone. In the mic array mode, you can see all the different ways to set that up. And then there's things that you can tweak within the audio file as well, so like acoustic echo suppression, noise fill, noise suppression, a number of things that you can play with to manipulate audio. Now for speech recognition applications, if you've never built a speech recognition application before, this is your quick and dirty 101, if you will. What you're going to do is you have a grammar, and this is what you're listening for. You're waiting for that person to say, OK, cancel, give me the balance. If you've used a voice system, you're calling your bank, for example. The grammar is those set of commands that you're waiting for. If you've seen forward sync, it's looking for, say, the artist, or it's looking for the word destination, or it's looking for a street address, and so forth. So that's what represents the grammar. We're going to take the Kinect audio source, the actual buffer, send that to the speech recognition, and it's going to determine whether a value is sent to that grammar. Now, there's two ways to build a grammar. There's a simple way to do this programmatically, and you may, for example, want to do this with data from a database. You can imagine, say, letting somebody search for an inventory ID, and you pass in a number, and give me the current quantity for a specific inventory ID. There's a grammar builder and then choices, and a choice represents each item, and of course you can do this programmatically. Now for things where you have set values, there's the speech recognition grammar specification, and that is an XML file that represents the choices that you can have. So we're going to look at one in just a second. The point is that the speech SDK ships with a number of sample grammars that you can use in your application. Note that you should set automatic gain control to false when you're using speech recognition applications as well. Now the grammar file. So what you see on the left is this srgs, a file that we mentioned a second ago. And this is the sample file for a yes or no. So there's a specific rule ID, confirmation yes or no, and it gives you examples. And then it references other rules. In this case, what you see on the right is a reference to the yes confirmation. So you can see the different ways that, for example, if you want to say, would you like your latest balance, and it's waiting for a yes or no, there's a lot of different ways that you can respond. Yes, yes please, yes, yeah, yep, okay. And you can imagine the same thing for no. So the point is, rather than you having to build these yourselves, you can set this XML file and pass this into the speech recognition engine for a specific command like, hey, based on where we are now, we want to have a confirmation, and you can reuse these grammars. And there's really nice for things like dates and times and so forth. Rather than you having to build them yourself, use the sample grammars. Okay, so let's go into code. So the first thing we're going to do is show how you can record a WAV audio file in WPF. So to do that, we have a sample here that's an audio recorder. And this audio recorder, really the code is based on the SDK sample, console sample that ships. There's a couple different things that you need to do for WPF, and that's really what we want to spend the time highlighting. So let me just show you how this application works. It'll ask you how many seconds to record, and we'll just record 2 seconds. And remember, my microphone is over there. So test, 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 test. So it's recorded my audio. Now I'm going to try and play it back, and hopefully you all can hear this. Test, 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 test. All right, so there's my awesome recording application. So what's going on under the covers? Now at our top of our file, we have a reference to the Kinect.audio namespace. And really the things that, there's a number of things that we're doing to set up the application and so forth. The big thing is the actual recording needs to happen on a separate thread. And in particular, it needs to happen on a thread where the apartment state is multi-threaded apartments. So if you, Windows Presentation Foundation by default is an SDA single-threaded apartment. If you try and use the Kinect audio source on an SDA thread, it will throw up on you. You don't want that. What you need to do is set this to a multi-threaded apartment and have the actual recording happen on an MTA thread. So here we're recording audio. And I'm just going to skip through the basics of the code, but we create a new Kinect audio source. We create a new file stream, and that's where we're going to be writing our file. The very first time in the beginning of the file, there is specifics to the header file that a WAV file needs. You can look through the code, and there is a walkthrough as well in the SDK, but that's just basically saying the type of WAV file that's going to be recorded. When we call source.start, that's actually going to return an audio stream. And we're using a using statement to automatically dispose of this stuff. But within this audio stream, we are going to read the buffer. And this audio stream, we can basically loop through and read what's coming back from the microphone. And we're not going to do anything special with it. We're just literally going to write it directly out to that file stream. So at that point, we click record, depending on the length, and for this specific application there's a recording length, but it's just going to write that data out, test, test, test. It hits the end of the file, and all that buffer information is written to the file stream. So that's our basic application of how you can use the Kinect microphone programmatically to record audio. In our next application, what we're going to do is use speech. And I want to show the code here first. Now we're going to use a couple different namespaces, Microsoft Speech Audio Format and Speech Recognition, in addition to the Kinect Audio. Second, I mentioned this in our first setting up our development environment. In this case, we're actually using the speech recognition engine that ships with Kinect is now going to be available on the web, and that's definitely what you're going to want to use. Within our Kinect audio source, we have a feature mode, and we can set a couple different properties. We're going to say Opti-Beam array only, for example. We can set automatic gain control equal to false, and in this case we're going to get the first speech recognition engine that maps to the Kinect recognizer ID, which is that one. So now we have the recognizer info, and really this is where we create the speech recognition engine. We build this list of choices. So in this case, this console application is going to listen for us to say these 3 words: red, green, blue. And we have a grammar builder. We set the culture, and then we append those choices. Okay, so at that point, we can load our grammar, and then we have specific events, and we'll see those events fired to display whether the speech was rejected, whether it was hypothesized or recognized. Now, just a couple more things here. Same code that we saw earlier, the source.start to get access to the audio file. And we can also do an asynchronous recognition. And let's just go ahead and show some of the different events as well. But from here, we're basically showing whether the speech is recognized, the confidence level and how it was hypothesized, and if there was a problem with the audio, we'll actually dump the recorded audio. Red, and there you see the confidence index. You see that it was rejected as well. Green, blue, red. All right, so there you see basic values here, and I'm sure it's going to start rejecting in just a second here. But we've set up our grammar, we've passed it in, and then we can, for example, know how close we think, based on the confidence level of what they said, maps to that specific grammar. So in this example, we've shown how you can use the Kinect audio source both to record audio files and use it in conjunction with the Microsoft Speech APIs to actually build a speech recognition application. So this has been all of the videos for the Kinect for Windows SDK Quick Starts. If you have questions, definitely let us know. And thanks for watching along.